In this demo, we'll look at Oracle Kubernetes Engine, also known as OKE to On-Prem disaster recovery setup. Oracle OKE is running 122.5 Kubernetes version, and on-prem Kubernetes is running vanilla 124.2 Kubernetes, and on-prem is also using CEPH storage, while Oracle side setup is using OCI block storage. So you'll also see how Swift helps you convert storages and remove that vendor lock-in for storage. This is also cross-environment, cross-version demo. Now let's look at the source environment. So this is 122.5 and this is running in US Phoenix region, and this has a node pool with 3 nodes. And since this doesn't support any dashboard, we have deployed vanilla or open source Kubernetes dashboard in this cluster, and we'll connect to that now. So here's that dashboard. So there is a namespace created called Blogger App Production. So this essentially it's running an application called Blogger App. It's a WordPress based deployment. It's a blogging application, and as you can see, it's running a bunch of services, config maps, persistent volume claims, secrets, etc. And the volumes are used are of Oracle block volume type. Now we have Kubernetes dashboard deployed to the target cluster to both Swift as well as Kubernetes in the DR side running on-prem. This can be essentially any third-party hosted environment too. It will work the same way. And we have Blogger app DR namespace created just to show that it doesn't have anything running. There is a secret created, image pool secret, which is for our RackWare transient agent image, pod of which is run during sync on both sides of clusters. And Swift can now actually automatically create this secret for you. Now let's connect to the Swift dashboard. We have set up initial password, so I'll just log in with that. So it dropped us on cluster admission. Now let's go ahead and add our clusters. We'll first add OK cluster, discover it under Swift, and then we'll also discover local cluster. Discovery typically takes just few seconds, and Swift will go ahead and discover all namespaces, all Kubernetes object, applications, and dependencies. So we'll add OK cluster, give it a friendly name. We'll select OCI as a type, and you just have to fill in few OCI cloud specific details like tenancy ID, OCI user ID, API credentials. And we can go ahead and discover this cluster now. The cluster is discovered, and if you expand it, you can go to namespaces and you can actually browse all the namespaces, all the object types. And this is the namespace we want to replicate. And as you can see, it has discovered all the objects there. So let's go ahead and add local cluster. So I'll name it local Kubernetes cluster, and then for local cluster, you just need API server IP and port, and then service account. And this service account need to be created just one time. I'll go ahead and add it. So this Discord should also be instantaneous. It's finished. And you can see it has discovered all the objects for this cluster too. Now let's go ahead and create the storage pool in Swift. I have added 2 virtual or block storage devices to this Swift VM. It's running as part of VMware environment, so I just added it to AMDKs. And what happens is if Swift is running in cloud, it will be any cloud object storage or cloud block storage. In this case, I'm going to just create one virtual pool. I'm going to call it Blogger Backup or Blogger Pool 1, like Backup Pool 1. So you can name it anything you want. And I have 2 disks which are available. You can browse here disks and select the ones you need. And I'll go ahead and create this pool. So backup pool 1 is created now. So anytime we do backups, we'll select this pool to do the backups. And you can see it's not using any use space right now. But as we start doing things, we'll see some users here as well as some compression and dedupe in play. Now let's go ahead and initiate the backup and restore operation. So what we recommend is you typically do backup and restore jobs explicitly, verify the target application. If everything looks okay, you can convert those sync jobs into recurring syncs by applying a DR policy against it. You can also apply a DR policy independently by giving the sync configuration. But this way it helps make sure you are replicating with sync configurations what you want. So we'll do stage one sync, which is essentially backup. So capture of all the objects data from source cluster, OKE cluster to SWIFT storage pool we just created. So let's give it a name. You need to give two ports, data port and control port. So these ports are used from the cluster service port range. So it will go ahead and open those in Cloud Firewall. Also for the application selection, I'll select the namespace. From namespace, you can select any particular microservice, for example, and it will find dependencies for that and back up everything around that. But for simplicity, I'm just going to back up the entire namespace because I know my deployment as well as stateful set are running as part of same namespace. I'll also give it a name initial backup because that way we can use this job for DR policy apply later to convert it into recurring syncs. Everything looks okay here. I'll go ahead and start the replication now. Now these ports, you can either specify specific ports or just whitelist the entire service port range and have Swift select those randomly. And this is the service transient service Swift will launch in respective cluster. I'm going to specify load balancer. So it will use WAN connectivity from lab to WAN connectivity all the way to OK to capture everything. And that's okay because all the ports, all the traffic is VPN encrypted with VPN grade security. If you have VPN, you can use that too, so it shouldn't happen. So backup job has started and finished because it's a small application. And let's go ahead and restore this. So for restore, you'll select stage 2 sync. Then you'll select the backup, which we created in the previous step. So only have one backup. So we'll select that. Then we'll select the target cluster. In this case, local cluster. It will show all the namespaces. So you can restore to any namespace. And we'll select the Blogger app DR namespace, which we have created for testing, which is not running anything right now. And you can select the storage types available in the target cluster. So here we will select CEPH storage. So now all the OCI volumes will be converted to the CEPH storage for the first sync, and subsequent syncs will retain those volumes and just do the delta sync. Now you can also do a lot of reconfiguration as part of syncs. You can apply pre-post scripts or pre-post YAMLs as part of restore operation, which I'm not going to do in this case. You can also specify what resources you want the transient pod generated by Swift to use. You can also change the registry endpoints. You can also do volume excludes. And in this case, I'm gonna do the service config. So we have one load balancer service, but there is no load balancer service possible in local clusters. I'm just gonna change that to node port type. Also, I'm gonna change the node ports of that service to randomize it. Now you can change those to specific target node ports which are free in the target or DR cluster, or just ask Swift to randomize. In this case, it doesn't matter what port it uses after replication, so I'm just going to use the random ports. Ask Swift to randomize those ports during replication. So I'll start the sync. So restore job has started. Restore job finished. Now let's go ahead and verify the target application through the DR cluster dashboard which we have deployed. Let's select the namespace. And we can see everything is green here. So all the pods, stateful sets, deployments, config maps, secrets, everything is restored. Also, you can see that service types are changed, and also the volumes are converted to the CEPH storage type, and all the labels, etc., on all objects are retained correctly. So it may do some changes to objects in order to make sure like application runs. Now let's go to the source. Let's connect to the application. So we'll just verify the data. So it has one blog running because this is a Blogger application. You can also connect to the dashboard and see that it has only one blog. Now let's connect to the target application. Now target application, since it's connected to node port, we should be able to connect it using the node port IP and actual node port of the application. So we'll just grab that. So it's running on this port. So let's connect it locally, and there you go. So you can see the application is just fine. It's running okay. Now let's go ahead and create some data on the source application, because now we are about to convert the sync jobs into recurring syncs as part of DR policy. So you'll see SWIFT is doing actual delta sync. So I'll create a test post here to generate some additional data. I'll publish this post. And if I go to the dashboard, I'll see two posts now. Of course, this post is not going to be there right now in the target cluster. So it will come up after first sync as part of DR policy. So let's go ahead and create a DR policy. DR policy is a simple configuration where you tell like the frequency of recurring syncs. Also, you can configure alerts, email alerts. So I'll call it stage 1 to policy, and that's what we want to do. Stage 1 and stage 2 both, like backup and restore. We also want them to run back to back, though you can run them with independent frequencies. Here we'll select backup every 30 minutes, and we'll select restore after, right after the stage 1 or as soon as backup finishes. I'll also specify email for alerts, and I don't want all alerts. I just want to be notified when something fails. So I'll select this, and I'll apply this policy. So policy is created, but it's idle because it's not yet applied against any sync jobs, or we didn't specify any sync configurations. You can specify apply. So you can specify new sync configuration here, but since we already tested syncs with explicit backup and restore jobs, I'll just select those jobs and ask it to import configuration from there. And if whenever this policy is failed over and you want to fail back, so that will be synced from your current DR to your original production OK, so on-prem to OK. So you may want to specify this source configuration. Fallback is optional, but in case you use it, so here's the configuration. Here's where SWIFT will generate those volumes back. I'll apply this policy, and policy is going to start immediately because that's what we asked it to do. So it's active now, and you can see already it started the first backup job. So this sync is going to be like a delta sync for both backup and restore. So it will only copy what's changed. You can actually see the sync progress as well as part of checkpoints. Similarly, if you go to the completed sync jobs and if you expand those, you can see all the details like all the checkpoints or what all objects were backed up or restored. Also like data statistics, volume statistics, per volume statistics, like how much data was transferred per volumes, etc. So let's go back to our sync. So backup finish, so restore should start immediately because that's what we configured in the DR policy. And you can see that source application is still up. There is no effect whatsoever. Like it's running, it keeps running, there is no impact. Our restore job finished too. So let's go to the target dashboard and connect to the DR application again. It looks okay in the dashboard itself, so you see everything is replicated, all the volumes are retained, labels are retained. Now let's verify the application to verify that data also is retained, and it did delta sync. So we should see a new blog which we did on the production application. So let's find its target node port and connect to that. So let's connect to this node port. And there we can see that the DR application is showing all the data from source. We see the new push. We can also connect to the admin interface. We should be able to log in with source credentials because this application is a replica of the source application. We see all the data, all the configuration here. We can see the post and post configs here correctly. Now let's go to the DR policy and let's assume that at this stage that it's active, but you have production failure and you want to failover. It could be for testing or it could be real failover. You just select the policy and you get option to failover here policy. It's all automated process. If you press failover, it will give you a choice of whether it's a drill or real failover. In this case, it's a drill failover. So drill just lets it know that this is for testing. And also when you fall back, it's not gonna do reversing by default if it failover with drill mode. You can force always like a reversing as part of fallback. Similarly, here, like as soon as you fail over, it will check if there are any outstanding changes. Since there are none, so it immediately move to failed over state. At this stage, your DR is ready. Then you can test it or bring it as a production if it was real DR failover. And once you're done, if it was for testing, you can always fall back. And if it was a real DR failover, then you can still fall back. Only difference between drill and non-drill is like whether reversing is performed as part of fallback. It's not performed for drill mode, though you can force that. So I'm just gonna fall back. And it immediately went back to fall back because it sees everything is already synced up. So that's what we wanted to show in this demo, how to set up DR policy between OKE to on-prem. Thank you.